Okay, what is a definition of solubility? How much of a substance can dissolve? That is partially right. The maximum. The maximum amount of solute that can dissolve in what? A given volume of and the reason it's the given amount of solution is, how do we find molarity? Molarity is moles of what? Solute divided by liters of solution. Yes? So it is the maximum amount of solute that can dissolve in a given volume of solution, because that's why we have that solution there. So that's one definition. This is the best, I think, of the two definitions. This is good for both dump and stir and mix and match. Now, if you're like, what the heck is dump and stir, and what is mix and match? See if you can think about that and tell your partner what you think of those. Dump and stir and mix and match are both methods of creating a saturated solution. Yes. Please describe to your partner the dump and stir method. This is the really complicated one, right? What do? You dump. What do you dump? The solute into a, well, we'll say solvent, okay? And stir. Is that it?
Until like they dissolve.
Repeat until
A precipitate.
not until a precipitate forms. How would you know you are saturated? Until some solid will remain, will not dissolve, okay? Until some solid will not dissolve. Okay, so that is our dump and stir. Yay. Okay, let's do describe to your partner, please, the mix and match method. This one is more complicated. Yeah, what are you mixing? What are you matching? What are we mixing? Solute? Sorry, what, Amy? 2 solutions. Each solution now, if we're trying to precipitate A plus and B minus, what should one of the solutions contain? A plus. What should the other solution contain? B minus. So each solution should contain one of the ions. In a low solubility compound. So for example, solution A contains AgNO3. Solution B contains Can anything, tell your partner what you think perhaps solution B could contain. If you're looking at your data booklet, you are on the right direction. You're on the right track. Yes. Solute is what you put in, solvent is what does the dissolving. The solute dissolves into the solvent. So salt, solute, water, solvent.
So solvent is what you are putting the solute
Into.
Oh.
Yeah. Okay, this would be like for dump and stir. I should have drawn it up with dump and stir, but the question came now, so that's where it went. Yes. Sorry? NaOH? Sure. Absolutely. And who is the ion of interest there? OH. Yes? As long as the concentrations are sufficient, a precipitate will form. For which of these are the coefficients used for the ion concentrations? Dump and stir. Mix and match, do we use the coefficients? No. Is good. And now we're going to start doing some math. Okay? Oh no, the math is good. This is easy math. You'll be like, oh, easy math. Easy math. We're going to start with solubility, which we have just defined. What's the unit of solubility? Moles per liter or molar. Okay? And we're going to take our molarity and we are going to find our KSP. And here is how you do it. The first thing you do is you write the solubility equilibrium equation. Yes? Then you write the KSP expression. You find the ion concentrations. These will all be dump and stir type problems. Okay, and they will be proportional. The ion concentrations will be proportional to the coefficients. And then all we do is we plug into KSP and we solve. You can do steps 1, 2, and 3 in any order that you like. I like to do the C and KSP first because they're required for all the different KSP calculations that we will be doing. And therefore, if you get a half a mark for one and a half a mark for the other, you're guaranteed to get 1 mark, even if you have no idea what to do next. If you're like, I don't know what type of problem this is. Is this a solubility to KSP? Is it KSP to solubility? Is it will it precipitate form? I don't know, but I know I can write a solubility equilibrium equation and a KSP, and I've got 1 mark. Phew, right? Okay. So let's say we have here the solubility of barium sulfate is found to be 1.0 times 10 to the minus 5 molar at 25 degrees Celsius. Calculate the KSP for BaSO4. How can we tell that this is a dump and stir type problem? We're only talking about one substance, right? And that is our low solubility substance. BaSO4. All right. So let us do our thing here. You need to write the solubility equilibrium equation. What's the next thing we need to write? KSP. I'm going to leave a little room underneath my solubility equilibrium equation because that means I can write my ion concentrations underneath. Okay, so I'm going to leave some space. And then we're going to write our KSP. So what do I need in order to calculate the KSP? I need the ion concentrations, and one way of showing the ion concentrations is to say, what is the concentration of barium sulfate? 1.05 times 10 to the negative 5 molar. And I'm putting it in brackets because it is a solid. So what is the concentration of barium 2 plus? 1.05 times 10 to the negative 5. And what is the concentration of SO4 2 minus? 1.05 times 10 to the negative 5 molar. It would also be, so this is one way to show ion concentrations. Another way would be to say concentration of barium is equal to concentration of sulfate is equal to the concentration of barium sulfate, because they're all 1 to 1 to 1, which is 1.05 times 10 to the negative 5. Molar. So we get 0.5 marks for the C. We get 0.5 marks for the ion concentrations, or 0.5 here for the ion concentrations, and we get 0.5 for our KSP expression. And then all we have to do is stick in our numbers, 1.05 times 10 to the negative 5, and I'm lazy, so I'm just going to put squared, and that is equal to 1.05 e negative 5 squared, 1.1025 times 10 to the negative 10. How many sig figs should we have in our answer? We should have 3 sig figs. 1.10 times 10 to the negative 10. And we are done. Is good? Yes. Yeah, you should have the SEE if you're using KSP at any point. And you only need to show one way of finding the ion concentration. You don't need to do both. Okay? Yep. Is good? Okay. A saturated solution of silver bromide contains 1.33 times 10 to the negative 4 grams per liter. Calculate the KSP for AgBr. You need to recognize that this solubility is the concentration of a saturated solution, and that it is in grams per liter. Can we do calculations in grams per liter in KSP? No. KSP, we need moles per liter. So what we're going to do is we are going to calculate the concentration of AgBr in moles per liter. Do I write it like this? Is that what I write? Or is there a better way to show that I am calculating the molar concentration of AgBr? You guys know how to show molar concentration of AgBr. What do we put around the AgBr? Square brackets. Not that it's entirely wrong to say the molarity of the AgBr, but it makes you look ignorant. Yes? Do you want to look ignorant? No. You want to look like you know. You're a chemist. I know how to show concentration of AgBr. Like, as a person who's been teaching chemistry for years and years, I would never write that, ever. Like, it just seems weird. It would be like, I don't know. It's just odd. You know, it's like when you're, I don't know, it's just like conjugating a verb wrong, which is okay when you first start out, right? Like if you're learning a second language, no problem. But by the time you're getting into university, you want to be using the correct formatting for things. Yes? Okay, cool. So we're going to have 1.33 times 10 to the negative 4 grams per liter times moles per liter. Oops, no. What do I want on the top and what do I want on the bottom? I want moles on the top and I want grams on the bottom, and I would get 107.9 plus 79.9 equals 187.8 grams per AgBr per mole. Which is 7.082 times 10 to the negative 7 molar. Yes? And we really don't have much time to do this. We have 2 minutes. Okay. Speed. Here we go. AgBr solid in equilibrium with Ag plus Br minus aqueous. .08 times 10 to the negative 7 molar. 7.08 times 10 to the negative 7 molar. 7.08 times 10 to the negative 7 molar. KSP equals Ag times Br equals 7.08 times 10 to the negative 7 squared equals 5.01 times 10 to the negative 13 is good? Okay. Your homework has nothing to do with this. Your homework is about section 3.2, which is pages 42 and 43. Okay. On changing and defining solubility, about saturated and unsaturated reactions, the rate of the forward and reverse.
What? Oh.
And page 56, that's dilutions and mixing. Okay, and the video is posted on Teams. Yay. Thank you guys so much.